Welcome back, my dear students. Welcome back. How are you all, beta? How are you all? A very happy good evening to all of you. स्वागत है बेटा आप सभी का. Everyone, beta, first please confirm me. Audio and video is crystal clear to all of you. Everyone able to hear me, see me. Can we start today's beautiful session, beta? Just write crystal clear in comment section, beta. Audio video crystal clear. Okay, beta. Shushmit Nandi. Okay. Fantastic. So now we are in lecture number 2. Rate of reactions and basic numericals. As you all know, this side Gaurav Srivastava sir from Engineers Institute of India with 14 plus years of teaching experience as GATE Chemical Engineering Educator, author, multiple GATE top ranks with current year top rank of AIR 43. Okay, so I hope beta in lecture number 1 you have no doubts. If yes, then one more time beta you have to write crystal clear sir. Very happy good evening, very happy good evening Prashant Kumar, Kiada, Shushmit Nandi, Rank वन everyone बेटा you are all welcome, you are all welcome. स्वागत है आप सभी का. मैं ना हुसैन बेटा, very happy good evening. And everyone बेटा please share the class link in all groups in which you are present. अपने मित्रों को, friends, junior, senior, everyone बेटा please don't forget to share. Okay. And everyone beta those who want to join EII all paid classes, then admissions are going on beta. New batch just started. Two live subjects are going on, one CRE along with heat transfer operation. And just in first batch we had completed for 2026 process calculation and mechanical option solid handling. You will also get recording for these two subjects, and don't worry, if you want to see again them live, you will see again after taking admission MOSH and process calculation live classes. Okay, so if you want to crack it with super rank just in one attempt beta, then just believe in me, believe in ourselves. Just for next 9 month approx beta, definitely you will get your dream rank if you are going to follow me strongly. Okay, so without any delay I'm going to start today's lecture beta. In a previous lecture we had seen few things about thermodynamics of chemical reaction, and you had seen when you are going to see thermodynamics, two important things are there. One is heat of reaction and the second one is feasibility of a chemical reaction. Whenever you are going to see feasibility of a chemical reaction, then it is directly related with Gibbs free energy. And you had seen few details, just a concise form, because the detailed version of Gibbs free energy you will see in thermodynamics subject. Okay, in thermodynamics. So here just you had seen a concise form, like the energy that is available to do some useful work is known as Gibbs free energy. With proceeding chemical reaction, Gibbs free energy decreases. That means for a spontaneous chemical reaction, delta G sign will be negative. Okay, so now again I am going to start this thermodynamic topic in little bit detailed manner. Sir, can those who joined before can attend PC and MS again live? बेटा this thing I can't say कि आपने अगर पहले किया है फर्स्ट बैच में लाइव, so again you are able to join or not. You have to ask with राजेश सर, क्योंकि इसके जो फर्स्ट टाइम आएगा they can see. But if you had already seen one time live, then if you have any problem, then in that case अगर कुछ मिस हो गया था तो आप बात करना, अलाउ करा देंगे, कोई दिक्कत नहीं है, अलाउ करा देंगे. ठीक है. Now, so today we are going to discuss heat of reaction and as well as the second part, feasibility of chemical reaction in detailed manner. So my dear students, please write the first heading, heat of reaction. Heat of reaction. Everyone please write beta. Heat of reaction. So what is heat of reaction? Already if you had seen my process calculation in paid batch. Then already we had discussed in energy balance, but here again I want to discuss it with one beautiful diagram. So suppose, my dear students, you have to convert reactant R into product P. You have a reactant, okay, and reactant is R, and you want to make product P. You have a reactant R, and you want to convert this reactant R into product P. Okay. Now, if I'm going to plot one beautiful graph here, and this graph on y-axis I'm taking energy. This side, my students, you are taking energy, and this side reaction coordinate. What is reaction coordinate? Just you can feel like time. You can feel like time. Okay, so either you can write time or you can write reaction coordinate. You will see again about it in my subsequent lecture in more detailed manner. Okay, so here energy, here reactant, reaction coordinate. And why, sir, you are making two graphs? Because two types of reactions generally can happen. One is neutral, okay, but other than that, two, one is exothermic, one is endothermic. So for both cases, we want to draw this beautiful diagram, that is energy versus time diagram. Energy versus time. Okay. And you all know what is exothermic versus endothermic, but again, I am going to discuss here in some detailed manner. Okay. So in the first case, suppose, my dear student, this is your reactant. This is your reactant, and still you can see reaction is not started yet. But now we are providing some energy from outside. So we are increasing energy of reactants. And after some certain point, what we had seen, that now reaction already started, and now after some time we are getting our respective products. What is this, sir? Beta, this is activated complex. This is activated complex. You will see again in the same CRE subject about activated complex when I will show you activated complex theory after, I think, just one or two more lecture. Activated complex theory. This time just you can feel like some intermediate. That means first R is going to convert it into activated complex. Then that activated complex is going to convert it into product. That's it. Okay. So here clearly you can see this is the reaction path here on this diagram, and this is the amount of energy that you had given here in order to start the reaction. In order to start the reaction, this minimum amount of energy that is required in order to start the reaction above the average energy of reactants are termed as EA, and this EA is activation energy. Sir, is it that's it about activation energy? No, beta. Again, you will see activation energy in more detailed manner just after few subsequent lecture. You will see with many graphs. Okay. So this for this time, just feel it. This is one type of energy that is required. That is required in order to active our reactants. That is, without giving this activation energy, your reaction can't start. आप इस activation energy को नहीं दोगे बेटा, आपका reaction start नहीं हो पाएगा. Okay, are you getting my words, बेटा, everyone? So we are providing R to this EA, and activated complex is there, and once this activated complex formed, then it is going to again converted into products. Very good. In this case, clearly you can see the on this energy diagram, the energy of reactant clearly less than energy of product. Energy of reactant is clearly less than energy of product. Okay, no problem. Now again I want to draw the same diagram, but this time what we had seen, that if this is your reactant, then it is taking some energy, but the product is going to formed here. Product is going to formed here. Now again, if you want to check what is the value of activation energy, my dear student, for this case, then this time this, that means activation energy you are checking from the reactant side. That means how much energy present in excess from their respective average energy of reactants. I will give this definition again, and also with the help of few scientists, Arrhenius, and also few more theories, collision, transition state theory. And in that part, we will discuss it in more detailed manner with a more feeling of activation energy with many numericals. Okay, for this time, just feel it like that this is some type of energy that is required in order to active our reactants. Now, so here again, you would make activated complex, and again they are going to convert it into products. But what you had seen, यहाँ क्या देख रहे हो बेटा? What you had seen here? Clearly, my dear students, you can see for this second case, ER is clearly more than EP. Now, if you want to calculate heat of reaction for these two cases, then see beta. Here heat of reaction for this case is energy of product minus energy of reactant. If you want to write here, again my dear student, no need to worry. Again it will be energy of product minus energy of reactant. Clearly, see beta, clearly you can see in the first case, ER is less than EP. That means EP is more. That means beta you will get it as a positive quantity for this case. But here ER is more. So less minus more will provide you what? It will provide you negative value. But we know beta, according to law of conservation of energy, energy is conserved. Energy can neither be created nor be destroyed, only it can transform from one form to another form. So here the chemical energy is going to convert it into heat energy, or some heat energy is going to convert it into chemical energy. For this first case, clearly you are seeing that P having more energy, but here P having less energy. So here clearly you can see this is the amount of energy that you can write here as heat of reaction. Here again, this is the amount that you can write here as heat of reaction. And clearly beta here P minus R will be a positive quantity, and here P minus R will be a negative quantity. So clearly here you can see that during reaction definitely some type of heat energy is going to absorb from outside. Heat is absorbed. Heat is absorbed. What is the meaning of heat is absorbed? Beta? Heat is absorbed means heat is going to convert it into some other form. What is heat? Heat is a form of energy. Heat is a form of energy. Work is also energy. Chemical energy is also there. So many types of energies are there. So heat is absorbed means that heat is absorbed and converted into chemical energy. And when we are going to write energy balance equation anywhere, energy balance equation, in that energy balance equation, only and only the energy that we are going to consider directly, that is heat energy. That is heat energy. Okay, so if we are not going to write in that equation how much heat energy is disappeared, or how much heat energy is additionally there, not produced, but you can say changed from some other type of energy, like chemical energy is converted to heat energy, then definitely that energy balance is not consistent one. So my dear student, here it is absorbed, but here heat is evolved. Here what is happening my dear students, here heat is evolved. यहाँ हीट क्या हो रही है बेटा, निकल रही है. बोलो सभी को समझ में आ रहा है ना? एक बार बेटा सभी लोग कमेंट सेक्शन में लिखोगे. एवरीवन प्लीज राइट. एवरीवन बेटा प्लीज शो मी एनर्जी and be active in comment section. Everyone please tell me beta, is it crystal clear to all of you beta? Please everyone tell me. Everyone beta please show me energy. Just focus beta, just focused. Okay, fantastic, mind blowing, super yeah, super. So heat is absorbed or heat is evolved. If heat is going to absorbed, then my dear student, these type of chemical reactions are known as endothermic reaction. Endothermic reaction. बट इफ हीट इज गोइंग टू इवॉल्व, हीट निकल रही है, निकल कहां से रही है, फ्रॉम वेयर इज इवॉल्व, heat energy is conserved. That means some chemical energy in that reaction going to convert it into heat energy. So heat is evolved there, and if you're not going to remove heat from there, then heat energy is responsible for temperature increase or decrease. So definitely temperature of that system is going to increase when chemical reaction proceeds. Okay, are you getting my words? Everyone crystal clear? Yes, sir, crystal clear, sir. So this is what my dear student, this is exothermic reaction. ये कैसा reaction है रे बेटा? This is exothermic reaction. And if you're focusing better just like this topic, complete CRE is same to same, you will feel very easy. And here I'm not going to discuss just 30-year question paper, more than 36 plus years. Even I have problems of 1983. Okay, so I'm not going to left a single problem. I will share lots of practice sets too beta. And the main thing, good thing is here that we are also seeing what is the time that we are taking to deliver these things, because we can't take like full year, 1 year just CRE. So the things will be in scientific manner so that in very less time you will get too much content. And the good thing is with crystal clear concepts with 0% darkness. So again, I am repeating beta, if you are feeling a single percent darkness in any topic, please don't allow me to move forward. Ask me again and again till you are feeling will tell you that now 0% darkness is there, 100% crystal clear. Okay, so here, my dear student, this is activation energy. This is activation energy. Some more thing, if you want to know about activation energy, I will tell you later again. But here, just see one more detail. Suppose this is reactant number one. Suppose this is reactant number one, and this is reactant number two, and they want to react. So, in order to react them, two important things are there. They must be collide, and not only collide, they must collide in proper orientation. What is proper orientation? What is a proper orientation? See. Suppose this is one, and this is the second one, and it is going to hit this molecule like this. They are colliding. What we are seeing? No reaction happens. Again, they are colliding, and this time they are colliding like this. Again, no reaction happen. But again, we are colliding like we are seeing like this. They are colliding like this. Oh my god. Oh my god. This time what we are seeing? Reaction happens. Product formed. This is proper orientation. So for every reactant, there is a respective proper orientation. That means they are colliding with each other. They are colliding with each other, but with all collisions, reactions are not going to happen. Reactions are happen only with the collisions. That collisions are known as effective collisions. That collisions are known as beta effective collisions. Now see again, this is going to react with this one, and the orientation is also proper one, but again no reaction happens. What is the reason? Why? Can you tell me, my dear students, why? Because in first part I told you that if effective collision are there, they are colliding in proper manner, in proper orientation, then reaction happens there. But now what I'm saying, proper orientation is there, reaction is not happening. Can you tell me in comment section, everyone, please, but everyone, please tell me why this is happening here. In this case, why? प्लीज टेल मी बेटा, एवरीवन प्लीज टेल मी व्हाई इट इज हैपनिंग यार. ऐसा क्यों हो रहा है? इसको तो रिएक्शन करना चाहिए ना. दिस मस्ट बी रिएक्टेड बिकॉज दिस टाइम प्रॉपर ओरिएंटेशन इज देयर यार. प्लीज टेल मी एवरीवन प्लीज टेल मी बेटा व्हाई इट इज हैपनिंग. Why it is happening? Why reaction is not happening? Any one of you? If don't know, then you can write R in comment section. If you don't know, then you can write R in comment section. If you know, then please write your answer in comment section. Very good beta, very good. No beta kya das, no required energy. Very good beta Neeraj Kumar. That means this time the energy that is available to them, excess energy that is available to them, excess energy. If you don't want to use access term then wait. This complete energy at the time of reaction is known as threshold energy. I will give notes about threshold energy later, don't worry. So this time I'm just representing in a short form ETH, threshold energy. What is threshold energy? I will tell you later. This time just you can feel like this is a total energy. Okay. So clearly the threshold energy will tell you, that the minimum amount of that energy is available. Why I'm saying minimum? If more than minimum, is it still reaction is going to happen? Yes, it is going to happen. If less than minimum, it is not going to happen. If more than minimum, it is going to happen. So the critical point is that minimum point from their average, in excess of their average energy. So that is known as activation energy, and this time, my dear student, the energy available there is clearly less than the energy required to react. That means till now you know, if any reaction you want to happen, then two things you must be remember, that they must be properly oriented, collision must be there, and at the time of collision they must possess their respective activation energy, otherwise reaction is not going to happen. Even if proper orientation is there, reaction is not going to happen. Okay, is it crystal clear to all of you, beta? You will see again these things in detailed manner, more detailed manner. Again I will show you, just and just you are dealing like introduction. Still we are in introduction because it's starting, we are just in lecture number 2. So these things you will see in the reaction theories like Arrhenius theory, like collision theory, like transition state theory, okay, or the activation energy from thermodynamics. Many things you will see in my subsequent lecture. Don't worry. But till now, the things that you had seen, please one more time, beta, tell me. Is it crystal clear to all of you? Can we proceed, beta? Everyone be active, beta. Everyone be active. सभी लोग active रहा करो. Please, everyone tell me. Can we proceed, my dear students? नो डाउट एट ऑल, सभी को क्लियर है बेटा? फटाफट बोलते चलोगे. एवरीवन एवरीवन प्लीज टेल मी बेटा. नो डाउट्स. Okay, so now I am going to ask a beautiful question that is relating adiabatic reactors. What is adiabatic reactor, sir? Okay beta, okay, crystal clear. Twins मेहरा हुसैन, सुस्मित नैंडी, क्या दास, नीरज, प्रशांत कुमार, क्या बात है बेटा? वेरी गुड, फैंटास्टिक. नाउ सी, in case of adiabatic reactors, sir, what is adiabatic reactors? Beta, adiabatic reactors means there is no heat interaction from outside, and also no, there is no heat exchange from surrounding से कोई heat का exchange नहीं होगा, no heat transfer to the surrounding. Okay, there is no heat interaction with the surrounding. So what is the meaning of adiabatic reaction? No heat interaction, no heat interaction, no heat interaction from surrounding, no heat interaction from सराउंडिंग. हीट का कोई भी इंटरेक्शन बाहर से नहीं होगा. दैट मीन्स एडियाबैटिक रिएक्टर्स. ओके, already in gate examination from this basic many questions you can find, and also in interviews. I will show you that PYQ soon, don't worry. So I am telling you beta, see, I am telling these things only for adiabatic reactors, non for non-adiabatic. Adiabatic reactors must be adiabatic for this statement. So I am asking, our reaction is exothermic. So I'm asking for exothermic reaction. One relation I will ask you for exothermic reaction. And second one, my dear students, you can write for endothermic reaction. For endothermic reaction. So exothermic reaction and endothermic reaction. I am asking only about the temperature of reactant and product relation. Very good question. So see, my dear students, here this is the temperature of reactant. Here also this is the temperature of reactants, reactant mixture, reaction mixture, and this is the temperature of product mixture. This is the temperature of product mixture. That means after completion of reaction or with proceeding reaction, you can say anything. So just tell me one thing, beta. Here, which sign you are going to use for these two cases? So just do it in your notebook and then compare with me. You can use three signs like this or this or this. Which one you are going to use here? Okay, suppose I'm telling this as A, this as B, this as C. So please tell me for first one, ABC, which one? For exothermic reaction, ABC, यहाँ क्या full करोगे बेटा? ABC, which one you are going to fill beta? Enamul, Kiadas, everyone please tell me. Which sign may hallucinate? Fastest answer A sir. A sir. Fantastic यार. क्या बात है. क्या ही बात है. Okay. I am not telling that this is correct. I want some more answer here. Okay, many students are now sending same to same here. A. Susmit Nandi, Inamul, Mehal, Hussain. क्या बात है बेटा. So product temperature is more. Why? Because you are not going to provide any outside energy, but heat is going to evolve, and you are not going to remove heat from that reaction mixture. And if it is evolved, definitely it is going to increase the temperature of that mixture. अगर हीट को रिमूव नहीं कर रहे हो तो सीधी सी बात है यहाँ उसका टेम्परेचर बढ़ाएगा, रिएक्शन मिक्सचर का टेम्परेचर बढ़ाएगा. Those students who are unable to feel things in Hindi language, don't worry. Whenever I am using Hindi term, that just a translation of last sentence. Okay, translation of last sentence just for feeling for Hindi learners. Okay, so if exothermic reaction is there, definitely it is going to evolve, and in this case, definitely the product mixture temperature is more than reactant. And similarly here, but can you tell me ABC for this endothermic, my dear students? I am getting just few comments from few students, but everyone here, I want comment from every student here. If you don't know, you can write R in comment section, but be active here. If you are be active in comment section, if you are going to active in comment section, you can feel my lecture just like offline classes here. आपको बिल्कुल offline जैसे feeling देंगे. So please be active in comment section बेटा. जैसे offline classes में yes sir, just like that I want here. I want comment here. Okay everyone. So Shushmit, Ayush, Mehna, Enamul, Mahalakshmi, Nair, very good, fantastic, mind blowing, super. So this time B is correct. B is correct. Why B is correct? Why? I am asking why. Heat is absorbed, and nothing you are going to provide from outside. Then heat is going to absorb from reaction mixture. So definitely the reaction mixture temperature is going to drop down. That means reactant temperature is more than the product side temperature because no heat interaction from outside. You can feel, you can take feeling like when you are taking in a glass some glucose there, just you can feel, then that glass is going to become cold. Or just if you are going to add some CO, calcium carbonate, CEO, calcium carbonate dissociated into CaCO2, and that CO is going to make add in the water, that is known as slacked lime. So you can also see heat is evolved on that reaction mixture temperature. You can feel from your hand it increases. Okay, and that increases in such a manner so that it is not going to convert it complete heat to the environment, because that is not adiabatic, but is still not completely going into the environment. That's why you can feel still it is hot for for some time. Okay, so I hope everyone is crystal clear about this topic, because this is already asked in GATE as well as in PSUs. This is already asked in GATE examination PYQ question. You can see, I will show you, don't worry, I will give all PYQ sets, and not only you're going to give in very less time, I'm going to solve all questions for you beta. Okay, so test method I will give you, don't worry. So GATE PYQs as well as in PSUs as well as in interviews beta, many times. Okay, यस सर. ओके, श्यान मुखर्जी भी आ गए बेटा. कहाँ थे अभी तक? अभी आ रहा है कमेंट आपका. इतना लेट ज्वाइन करते हो, व्हाई यू आर लेट बेटा? एवरीवन बी एक्टिव एंड ट्राई टू ज्वाइन क्लासेस ऑन टाइम. ओके, डन. ओके सर, ओके सर, ओके बेटा. So now, next point, that is feasibility of a reaction. The second part we are going to see now, feasibility of reaction. Feasibility of reaction, this is second one. First one was heat of reaction, this is second one, feasibility of reaction. Okay, so just I told you the feasibility of a reaction you will able to see with the help of Gibbs free energy. So change in Gibbs free energy, about this you will be able to know detailed about feasibility with the help of what is happening with change in Gibbs free energy. Change in Gibbs free energy. Okay, now here this is feasibility. So just in previous lecture I told you about the sign of Gibbs free energy, and three signs here you can write, numerically possible signs. Either it can be positive, it can be negative, और it can be जीरो. ये पॉजिटिव हो सकता है, निगेटिव हो सकता है, जीरो हो सकता है. सपोज बेटा दिस इज नेगेटिव वन, सपोज दिस इज जीरो, सपोज दिस इज पॉजिटिव वन. Now, what is happening there? If you want to know, then if the sign of Gibbs free energy is negative, that means just you had already seen the reaction is a spontaneous one. The reaction is a spontaneous one. And if the change in Gibbs free energy is zero, what does it mean? That means this time the reactants and products are in equilibrium. No net exchange is there. No net exchange is there. I am repeating, the reactant and products are in equilibrium. Here, please write reactants and products. Reactants and products are in equilibrium. Are in equilibrium. Are in equilibrium. Now, if this is positive, oh my god, reaction as impossible. That means the situation that you are giving is making delta Z positive on your paper. That means reaction is not possible in that condition. How? What condition? This is the condition regarding the change in entropy, and also how your what temperature you are providing, high temperature or low temperature. Okay. Now, in a thermodynamic subject you will see one beautiful relation you will develop there. Here directly I'm giving that relation, that is Z is equals to H minus Ts. I'm using this equation from thermodynamics. Don't worry, you will see a detail about this equation in thermodynamic subject. Okay, G is equal to H minus Ts. Now if I want to differentiate it, then how we can write dz, or if you are writing in delta form, so delta z is equals to delta h, and now here minus t delta s, and again minus s delta t. Okay, differentiation of two terms, first good a second plus second into first, my first का differentiation into second term plus first into second का differentiation. Now, if I am writing this for constant temperature, then definitely, my dear student, the third term in right hand side, you can make it zero. If if temperature is constant, if temperature is constant, suppose I am assuming here that during reaction I am giving some temperature, that making that temperature a constant, then definitely I can write this delta G equation just as delta G is equals to delta H minus T delta S. So this is the basic equation that you can use in order to check what is the sign of delta G. Is it positive or is it negative or is it zero? Okay, but for that purpose, you must know the what is entropy, because here delta S that you are seeing, the delta S term that you are seeing here, my dear students, this is what? This is entropy. This is entropy. This is entropy. S is entropy, and delta S is change in entropy. Change in entropy. Oh, okay. So what is change in entropy? Actually, this is the measurement of randomness. Entropy is the measurement of randomness. So you can write here measurement of randomness. Measurement of randomness. Okay, now entropy lecture already minimum more than 10 plus hour, only and only entropy 10 to 20 hour. So some educator deal in just 2 hour maybe, but here we are dealing, general time is nearby 15 to 17 hour. So what is entropy? Just here I am giving in less than 1 minute here, because this topic is already you will see in thermodynamic. So but just for your feeling, see, this is a room, this is the size of a room, and this is also size of a room, or you can say size of some city. Here many peoples are present, people number 1, people number 2, people number 3, people number 4, and you want to find them. And here in a very big city, like first time, some people you want to find in some city only, and this time you have to find the same people and number of people in a country this time, and you want to find one people there. So just tell me beta, in which case you are feeling there is a more randomness beta? Randomness किस केस में ज्यादा है? Case number 1, is it case number 1, or is it case number 2, in which you are feeling more randomness is there? Like here, if I'm telling that entropy is yes 1, here if I'm telling entropy is yes 2, then can you tell me in which case you are seeing more entropy value? इन दोनों में से ज्यादा वैल्यू कब है entropy की? Just tell me everyone. Everyone, please tell me in which case you are seeing more value of entropy is present. In which case? In case number 2, sir. क्या बात है, fantastic, mind blowing, super. So more randomness. That means large room, a small room, same number of molecules if there. Large container, a small container. Large reactor, a small reactor. Same number of components. So you can see and you can say that in which case the person that you are going to search or that particle you are going to search, easily you can search if there is a small room or a small container or a small reactor. If big one, then it is not easy. So it is a measurement of randomness. That means more randomness, more entropy. More randomness, more entropy. So clearly here, my dear students, you can see in case of this second one, S2 is more than S1, because here clearly you can see more randomness. Now, again you will see entropy in detailed manner in thermodynamic subset. Okay, very good, fantastic. My time, everyone, please tell me. No doubts on this slide. Can we proceed? Everyone, please tell me, beta, can we proceed? No doubts. All clear. Everyone, please, everyone, tell me. And also, please tell me streaming is okay, because I have LAN wire too. LAN wire भी है पास में ही था, अभी तो वाईफाई से पढ़ा रहे हैं. But if there is any problem, I will use that wire. कहाँ गया है जी? वायर तो दिख ही नहीं रहा. हालांकि I think streaming is okay, crystal clear. If buffering during lecture, then just ask me beta, because Wi-Fi device is little bit far from me, but still the connection is good. But if you are feeling any buffering, just I pause this class for 30 second to 1 minute, and I will arrange that LAN wire. Okay, so LAN wire को सीधे लगा देंगे हम अपने लैपटॉप में. So, sir, streaming perfect and all things crystal clear, fantastic. Now, see, uh, here I am making one beautiful table beta. First thing that I am writing, delta H. I will write the sign of delta H like positive or negative. And same thing here I am writing delta yes. That is a change in entropy during a chemical reaction. And now I want to check what should be the sign, just sign for this delta G is possible. And you just seen that delta G can be written as delta H minus T delta yes. So different cases I am going to take here beta. Different cases I am going to take here. Okay. Like I am taking endothermic, again endothermic. Why? Because one time I am taking endothermic reaction and where entropy also increases during reaction, and one time endothermic reaction is there, but there is a change in entropy is negative. That means entropy is decreasing during reaction. Then again same thing I am going to deal for exothermic reaction. Exothermic change in entropy is positive, then exothermic change in entropy is negative. And just I want to check what is the sign of this delta Z. Now, see the first case, that is for endothermic. Clearly, but you can see this is endothermic. These two reactions are endothermic. This is endothermic case. Okay, and these two clearly you can see, my dear student, this is exothermic case. So I hope it no doubt at all. ठीक है, are you able to connect everyone? सभी लोग feel ले पा रहे हो ना? Everyone able to feel it? If any doubt beta, immediately ask me, please ask me beta, immediately ask me. So I am worrying about the sign of this delta G. So how to check it? See, if delta Z is positive, I am putting here positive. See, here I am writing again this delta Z is equals to delta H minus T delta S. Now what I am asking here, I am telling you that if this is positive and delta S is also positive, oh my god, T is absolute temperature in Kelvin always we are using here. So that can't be negative for you. Minimum temperature that can be happen is zero and still the world record is just of 100 pico-Kelvin. So even you are not able to reach that 0 Kelvin temperature here. So temperature is not negative here because every time you are using absolute scale, that is Kelvin scale. So if both are positive, so we are worrying about the overall value of part, the second part, that is T delta S. If T is very very high, then this whole part value will be higher one in comparison to this part. Here what I am saying, T is very high, that was at high temperature, and when it is low, when it is high, then negative sign is more than positive sign when it is high. And when T is less value, T having less value, then the negative value T delta S value will be less than positive value. And here you are subtracting something from something, delta is always positive, so you are subtracting something from delta H. If you are subtracting more value, definitely the overall sign is coming negative. If you are going to write something like low temperature, then the delta Z will be positive. That means here we can give two conclusions here. We can give two conclusions. See, here you can give better two conclusions. So my dear student, the conclusion number one is, here the conclusion number one is at low temperature and at high temperature. Here you can see two conclusion you can give. So it will be negative. When it is in negative, see, negative sign is when T is more. That means it will be negative at high temperature. If the temperature is high, at high temperature, so the sign will come negative, and the sign will come positive when yeah, when it is positive, when the second term, complete term, T delta is complete value. It is not the value of just T, it is not just the value of delta S, complete value of T delta S. So if T is clearly less, so T delta S is less comparison to delta S. So clearly here you can get positive at low temperature. Oh my god. That means a beautiful statement here you already made, and this statement can be asked in your interviews as well as in gate examination. See what is the statement. For endothermic reactions, if the change in entropy is positive, reaction is feasible only at high temperature. Is it correct statement? Yes. Are you able to connect with this statement? का प्लीज एवरीवन टेल मी, क्या आपको समझ में आया जो स्टेटमेंट अभी हमने बोला बेटा? प्लीज एवरीवन टेल मी बेटा, आर यू एबल टू फील दिस ब्यूटीफुल स्टेटमेंट? एवरीवन प्लीज टेल मी माय डियर स्टूडेंट्स, कैन वी प्रोसीड? क्या सेकंड पार्ट को हम लोग डील करें? अंडरस्टूड सर, ओके, फैंटास्टिक, माइंड ब्लोइंग, सुपर, ओके. So now coming to the second part. Second part, revise second part. So in the second part, my dear students, clearly delta H is again positive and delta S is itself negative. Oh my god, negative will make it positive. Positive plus positive will give you sign always positive, even any temperature, it doesn't matter. High temperature, low temperature, it doesn't matter. Every time delta G here in this case, you will get positive. Are you getting my words, my dear students? Please एवरीवन टेल मी माय डियर स्टूडेंट्स, क्या समझ में आ रहा है आपको? आर यू एबल टू अंडरस्टैंड? Yes, sir. So here clearly it is positive and you can write here beta at all temperature. So what should be our conclusive statement for endothermic reaction? If change in entropy is negative, then reaction is not feasible at any temperature. Then the reaction is not feasible at any temperature. I hope everyone able to understand. And now I know that you are able to give conclusion for these two also. अभी आप इन दोनों का conclusion देने में सक्षम हो. Okay, yes sir, समझ में आ रहा है. So this conclusion please देने की कोशिश करो. Try to give conclusion for this exothermic reaction in the similar manner that you had seen. Okay. So clearly this time delta H is negative 1. If this is negative 1, delta S is positive 1. If this is negative, that means whole sign is negative. This is positive, then you can see for any t, it will always come negative. The overall complete sign will be negative. Negative minus negative will give you negative. Oh my God. What does it mean? What does it mean? That means this time you can see it is negative. Low temperature, negative. High temperature, negative. So feasible at all temperature. What is the conclusive statement? For an exothermic reaction, if change in entropy is positive, reaction is feasible at all temperatures. Are you getting my words every time, beta? Just like classroom, tell me yes, sir. So, everyone crystal clear, beta? Everyone crystal clear? Now, see the last one. See the last one. See last one, my dear students. So this time beta, this time, this is negative. So sign negative this side, and this delta S is also negative. Negative, negative will make it overall sign positive. This whole sign will be positive. That means now again the sign is going to depend upon the value of temperature. If temperature is more at high temperature, clearly you can see. If temperature is having higher value, clearly the magnitude of plus part will be more than this minus part. But if temperature is low, clearly you can see negative magnitude is more than this positive magnitude. So here again we can give two conclusions, beta. Here again you can give two conclusions. What, sir? So this is clearly you can see negative. When it will be negative? Can you tell me when negative, beta? At low temperature or at high temperature? Very good, beta. Kya das? Very good, beta. So at a low temperature, at low temperature, and it will be positive when at high temperature. So I hope beta everyone is crystal clear in this topic and able to give answer regarding this topic if they are going to ask in MSQs as well as in interviews or like OTQs. So the final statement, exothermic reactions are feasible only at low temperature if change in entropy is negative. Okay, बोलो सभी को क्लियर है? Can we proceed, my dear students? Tell me, beta, everyone, please tell me, can we proceed? No doubts at all. क्या आगे हम बढ़ सकते हैं? Okay. Okay, fantastic, mind blowing, super, super. So, beta, one reaction that you had seen Just very simple reaction like A is forming R. It can be like this, na. Some reaction can be like this, that A is forming R. A is forming R. So, beta, the first one is known as irreversible reaction. This is irreversible reaction. And beta, this is also, you can say, unidirectional reaction. Unidirectional, unidirectional reaction. And if reaction can happen in both sides, then that type of reaction can be given as name as reversible reaction. Reversible reaction. Okay, everyone crystal clear, beta? So now I want to discuss something about this reversible reaction. So next heading, please note down, beta. Reaction, reversible reaction fundamentals. Everyone, please write down reversible reaction fundamentals. Reversible reaction fundamentals. And make two graph. Why two graphs, sir? Again, beta, I will make one graph for exothermic, one graph for endothermic. Exothermic and endothermic. So suppose the first one is graph for exothermic reaction. Exothermic reaction. And the second graph that we are going to make is for endothermic reaction. And now you know how to make it, beta. अभी तो आप इतना जान ही गए हो ना यार कि बनाओगे कैसे. Endothermic reaction. So exothermic reaction and endothermic reaction. Okay. So again, the graph that you are going to plot here between energy that you are taking on this side, energy, y-axis, energy, and this side reaction coordinate, or you can say time. Okay. And you know well that how to make these. If exothermic is there, and if this is reactant, then it will move like this. And for endothermic, if this is reactant, then it will move like this. So this is reactant, this is product. This is reactant, this is product. Okay. Now the reaction, just as I told you, reaction is reversible one. So the reaction that you are going to write here, you can write R can be converted into P, and P can also be converted into R. Both possibilities are there. That means it is reversible in nature. It is reversible in nature. Okay. Like nitrogen plus hydrogen will give you ammonia, and ammonia can also dissociated into nitrogen and hydrogen. Okay, so reversible in nature, reversible reaction, both direction. It is not unidirection, both direction. Now what I want to discuss here, yeah. So here, if we want to check what should be value of that excess amount of energy from their average energy, minimum amount from R to P, then we are getting this is like this one, this. Okay, and this is in forward manner, this is in reverse manner. So I am writing this as EF, and EF is what? Forward reaction activation energy. And when P, see, this want to go to this side, then this is your value of activation energy. But suppose your P is going to convert it into R, यार. आपका P R में बदलना चाहता है यार. P is going to convert it into R. So this time our reactant is P, product is R. So this time suppose this side you are going, this side. So clearly This time this should be the value of activation energy. Are you getting my words, beta? So this is reverse reaction activation energy. This is reverse. This is reverse. This is reverse reaction activation energy, that is P2R. P2R. So my dear students, clearly you can see for exothermic reaction. For an exothermic reaction, you can see, my dear students, that E F is clearly less than ER. One more statement you got, that for an exothermic reaction, the backward activation energy value is more than the forward reaction activation energy value. Already these statements you can see in lots of PSUs as well. In interview they can ask you. Things are just fundamental and very very easy, and I'm telling you in easiest manner, beta, and I hope, beta, I am able to clear 100% doubts. Okay, so if still you are feeling any doubt, beta, no problem, just ask me immediately. Just ask me immediately. Okay, the same thing if you are checking here, yeah, in the second case, that is for endothermic reaction. So clearly you can see here, if R you want to convert into P, then this amount of energy in order to make activated complex. Hmm? But if R is P is going to convert it into R, then this is the amount required for reverse side. So for this case, clearly you can see here that EF having more value in comparison to ER. बोलो बेटा, सभी को क्लियर है? Can Tarun, can you sir once repeat what is reaction coordinate in x-axis? Beta, reaction coordinate, just you can feel that reaction is happening, reaction is going on. That means just with respect to time you can feel. Okay, and soon I will tell you in more detailed manner. This time just you can feel like a time. Okay, reaction coordinate, when reaction is going to happen, and when reaction is going to happen, what is happening there, and what is reaction coordinate in numerical values. If you want to see, then you will see later, beta. This time just you can feel like a temperature. ठीक है beta? Is it clear, beta Tarun? It's not temperature, sorry, time. Okay, clear? Okay sir, okay, fantastic, mind blowing, super. Okay, wait. Okay, एक important message था, done. So this is reversible reaction fundamentals. Now, why I'm saying these things to you, beta? Energy, clearly you can see, is related with temperature. If you are giving more heat energy to a substance, the temperature will be increases. If you are extracting heat energy from a substance, definitely the temperature is going to decreases. Yeah, but there is not a, we are going to exclude or exception, like no phase changes there, because when phase changes there, even if you're going to give heat energy, the temperature may remain constant, like liquid is going to vaporize. So during vaporization temperature is constant, that time that energy is used as not sensible heat, as latent heat. In Hindi गुप्त उष्मा, गुप्त है, छुपी हुई उष्मा है. But if some solid just you are taking, if you are giving heat energy, the temperature will increase. If you are going to extract energy, the temperature will be decreases. So here I am asking you, for the first case, that is exothermic reaction, at low temperature or at high temperature, at which time you are getting more yield of that product P from that reactant R? Or you can also say this like reactant R, yield of R. Yield of R, that means the R part, how much, how efficiently you are going to use here. So can you tell me, beta? Please tell me. Please tell me, everyone, beta. I am asking. Please, everyone, write in comment section, my dear students. Everyone, I want comment from each and every student here. I want comment from each and every student. Is it crystal clear to all of you, beta? So clearly here, for this case, if the reaction is reversible one, Can you tell me high temperature or low temperature? Which one should be favorable one from your side? Yeah. Because if see, okay, I'm repeating my question, beta. Just I'm asking. Uh, just you had seen this feasibility. Just you had seen this feasibility, and you had seen the exothermic reaction is feasible here at low temperature only when the entropy is negative. Okay, and something you are seeing, this is feasible at all temperature here. See, at all temperature. Okay. But for endothermic, only feasibility is at high temperature. Why only feasibility at high temperature? I will tell you again in detailed manner soon. But this time, just one part I am taking, this part. So this is feasible at all temperature. But here I am asking at which temperature you will get more yield of P, or you can say like more product at low or at high. At which one? Sir, buffering. No, but I am unable to see any buffering. See. But I am unable to see any buffering. See. Okay, everything is okay in my mobile here. Everything is okay in my clearly all okay here. See, I'm also seeing the lecture on my mobile so that I can feel is there any buffering or not. Okay, so lecture is also live on my mobile so that I can see no buffering is there, beta. So just check your internet connection, beta. Just check. So Smith Dandi low. Why it is low, beta? See, because the energy that is required here for reaction, the energy that is required here for reaction, clearly, beta, you can see for the first case, if you are giving or going to proceed this reaction at low temperature, what is going to happen at low temperature? What is going to happen here? See, the reverse activation energy value is higher one. That means you are not going to provide enough amount of heat energy, yeah? And if not available heat energy in enough quantity, then the more quantity is going to take for R to P. Still, P can go towards R because energy is there. If it is less there, then mostly it is going to take by R. R will get its complete energy. Yeah, I am going to get to P, but only few P is going to collect their respective activation energy. So clearly here, low temperature is good. Low temperature favors the reaction. And here if you are seeing beta for this reversible, and again I am telling beta, this is only for reversible. If this is irreversible one and I'm asking exothermic reaction, at which time, at what temperature you want to happen this temperature, this reaction, you have to tell. So high temperature, even if exothermic reaction is there, even if exothermic reaction is there and it is irreversible, at which temperature you want to do? Please tell me, high or low? Reversible. It is reversible. Reaction is reversible. No, irreversible. Reaction is irreversible. Reaction is irreversible. Exothermic. Tell me, at which temperature you want to proceed, low or high? Tell me. High. Very good, Tarun. It's high. So the thing that you hear normally that exothermic low temperature pe karao re bhai. Please do exothermic at low. That is for reversible reaction case. Reversible exothermic reaction case. Because at high temperature, the value activation energy reaction going to get easily, and one term you will see velocity constant. That is also known as reaction rate constant. The reaction rate constant value or velocity constant value, you will see it is higher side. So high temperature is good, but not good if the reaction is reversible exothermic. Okay, and clearly here, beta, the more one is you want. So if you are going to give you less amount, definitely is not going to favor your reaction. That means here high temperature favors the reaction. High temperature favors the reaction. Please tell me, everyone, beta. Everyone, please tell me. Okay, it is now crystal clear. No buffering, sir, for few seconds only on my device. Okay, beta. Okay. Okay, beta. Fantastic. Can we proceed, my dear students? Can we proceed? No doubts at all. Okay, fantastic, mind blowing, super. So the next one is heat of reaction, feasibility of reaction, fundamentals completed. Now we are going to see the fundamentals of rate of reaction. Rate of reaction. Reaction key, the rate of reaction. The rate of reaction is, what is rate of reaction? Clearly reaction rate. That means you want to see how fast the reaction is happening there. In short, you can say at what rate, in beautiful words you can define. Just previously, in previous lecture you had seen any chemical known by its chemical identity, and at what rate a chemical loses its chemical identity. At what rate a chemical loses, please everyone note down, everyone note down, at what rate, at what rate any chemical is going to lose its chemical identity. At what rate a chemical loses its, at what rate a chemical loses a chemical loses its chemical identity, its chemical identity is termed as beta rate of reaction. Rate of reaction. Okay, are you getting my words, beta? Please, everyone, tell me, is it crystal clear to all of you? What is rate of reaction? Is it clear? Just fundamental I shared, beta. Just fundamental, crystal clear, sir. Okay. So this is known as rate of reaction. Okay. So this is basic. Clearly, the value of rate reaction can be zero. If it is zero, what does it mean here? The rate of reaction, it can be zero. It can be zero. If it is zero, that means reaction is not happening there. Okay, or it is at equilibrium. So it can be zero or any positive, oh my god, positive, sir, yes, any positive finite value. But sir, we had seen some negative sign is also there. That is just a sign you are using there in order to make the complete value as positive one. So the rate of reaction can't be negative. It can't be negative. Why? How? I will show you later. I will show you later. Don't worry. Its magnitude, total overall, is a positive because it is the rate, that how much amount of that respective reactant disappeared. In Hindi, disappear means gayab ho gaya. Disappeared then that respective time. So the amount is going to disappear now. So is it any amount like -5 disappeared? If already you are using from your mouth disappeared, then why you are using -5 here? Just you have to tell 5. If by calculation you are getting -5, that doesn't mean the value rate of reaction is negative one. It is the positive value, positive quantity, and minus sign represented what? That the reaction that is written here is for reactant, and that is going to, because rate of reaction value you can also give for reactant as well as for products, as well as for reactants as well as for products. So the confusion may arise there, so please don't worry here. I will show you just after some time when I'm solving numericals and many things. Okay, so any positive quantity and any finite positive quantity you can say. Now see, I'm going here going to give you a beautiful example here. यहाँ ध्यान से देखेंगे. One beautiful example, please everyone, just focus here, just focus here. So in my example, beta, I am taking coal. What I am taking? Coal. Okay. So this time I am taking just one particle of coal whose mass 1 kg, and in second case lots of small particles of same coal whose total mass again is 1 kg. Okay, like you can say one powdery one and one side big particle. This is also cool. This is also cool. And you know well about fire triangle. What is a fire triangle? You know ना बेटा fire triangle जानते हो क्या आप? Please tell me. Any one of you? All of you बेटा know about fire triangle? जो नहीं जानता please write R in comment section. If you know then please write yes sir. You know what is fire triangle? This is fire triangle. You can see three arms are there. One arm having heat, one fuel, one oxygen. Okay, what is this? This is fire triangle. This is fire triangle. If all sides of this triangle are attached to each other, that means fire is going to sustain there. Yes sir, no sir. Okay, no problem. See beta tarun here. So fuel is there, like some wood is there. Oxygen is also there, but it is not burning. Why heat is not there? You are not going to provide their respective activation energy. Okay. Fuel is there. Heat is also there. You are using some sand and going to just uh, cut the oxygen connection with that fuel. Again, fire is not going to sustain there. Heat is there, oxygen is there, but fuel is over. Still no fire is there. So this is fire triangle. If all arms or you can say all sides of this fire triangle are attached to each other, only in that case fire can sustain. So definitely here fuel is present. We can provide heat also, but we need oxygen also. And you can send air as a source of oxygen here. Okay. So just coal plus air, and out of this oxygen you are going to take this coal, and it is going to make carbon dioxide. If some particles are going to get less amount of oxygen, then they can also make beta carbon monoxide. Both is possible. Both can uh, manufacture there. Both can produce there. Now I'm asking, in which case? See, this is carbon, but it loses its identity and going to convert it into CO2. Huh? So in which case, just tell me, my dear student, carbon is going to lose, complete 1 kg is going to lose its chemical identity in faster manner. Please everyone tell me, beta. Okay, very good, Rakyadas. Please everyone tell me. In which case? In which case? Is it case number 1? Is it case number 2? When it is fine, in case number 2 in powder form. Very good, fantastic, mind blowing, super. So definitely complete coal is going to burn in case number 2 in faster manner in comparison to that case number 1. Okay, are you getting my words, my dear students? Are you getting my words? So in both cases they are going to burn, but in case number 2 complete 1 kg, or if you want to show them in molar unit, then you can write like 1 kilomole. You can write like 1 kilomole. Then 1 kilomole means what? 1 kilomole means 12 kilogram here. 1 kilomole of carbon, that is 1 kilo atom of carbon, means what? I'm writing kilomole. You can write more precisely that accurately as 1 kilo atom, because C is atom. Okay. But to reduce confusion, every time I'm writing just mole, 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 mole. Okay. So 1 kilomole of coal you are taking. In both cases, 1 kilomole equivalent to 12 kilogram of carbon. So you are saying, sir, this will, if here the complete timing we are checking for this one, for complete burning, this time T1, this is time T2. What is time? This is time for complete, complete burn, complete combustion. That is T1 and T2. Clearly, beta, you are saying T2 is more. Absolutely correct. And now what you are saying here? Now, what you are saying that, sir, in case number 2, you are saying that, sir, in case number 2, the rate of reaction value is more than the rate of reaction value in case number 1. Is it the same thing, beta, you told me? Just tell me one more time in comment section, everyone. The same thing you told me now. The same thing you told me. Rate of reaction in case number 2 is more. Yes, sir. But this is not correct. Why not correct? Because when we are going to define rate of reaction just in this manner, yaar, it will create very too much confusion, because just for a single component we can't be able to give the respective value of rate of reaction, because it is going to depend upon quantity. So is there anything that is going to make it like universal? Like if coal is rate of reaction, then definitely you can say high rate of reaction. Some cellulosic reaction, low rate of reaction. Then is it anything that we can do here? Yes, we can take some basis of calculation. So here, suppose I am taking the basis as surface area. Why the second one is going to happen faster way? Because clearly the surface area, my dear students, in the case number 2, clearly you can see the surface area here. If the surface area is S1, here the surface, sorry, S2, this is case number 2 now, and here surface area is S1. So clearly the surface area that is available in case number 2 is more than in case number 1, and this is the reason why in the second case the reaction is going to complete at first. So how we are going to take this surface area in our calculation? It's very easy. So now see beta how I'm going to write rate of reaction, just a typical form. Rate of reaction, if I'm going to write like this, in numerator moles of carbon disappeared. If you want to write यार atom ही लिख लो यार, कहोगे सर मोल लिख रहे हो आप, क्या ही कर रहे हो. Just I don't want to make confusion every time एक ही चीज लिखते हैं, इसलिए because you are preparing for gate examination, you can write here atom, no problem. So here what I am writing, rate of reaction. So atoms of carbon disappeared upon time, but you are also writing here beta surface area. So if you are going to compare, when we are going to compare na, that for unit surface area, how faster they are. Suppose here the surface area, you are writing like S1, suppose I am telling as 5 meter square, and here this is suppose beta 50 meter square. Then 100% now you are going to get for this case T1, this T1 as 10 second, and this T2 as 1 second. Now you can see 5 into 10, here 50. 50 into 1, it's 50. Moles disappeared, 1 1 in both cases. So the rate of reaction is, clearly you can see here, in both cases it is same this time. Are you getting my words, my dear students? Please tell me, everyone. Please everyone tell me beta. Is it crystal clear? Can we proceed? Can we proceed? No doubts at all. Yes, sir. Okay, beta. Very good. Now, see one more thing. Can basis only be surface area? No. For the same reaction, you can take different basics. And which one is good for which case, you will automatically get after solving many numericals and after seeing few more theories. And I will also give basis along with their respective cases, because when you are going to react coal with oxygen, the main thing that is going to uh, change, or things that is going to focus from our side, is the surface area, or is how efficiently the coal is going to connect with oxygen, how effectively mass transfer is there, because this is solid, this is gas. So first is oxygen is going to diffuse from the bulk air to the surface of that coal. only when it is going to make connection with that coal, the reaction is going to happen. The reaction is going to happen only when the oxygen is going to connect or going to touch with that carbon. So if we are taking a big particle, definitely the inner carbon is unable to make a contact directly with oxygen. Only it will be available once the top layer is going to burn. So definitely the surface area is less there. So the main factor that is going to affect the rate there is surface area. So that's why for coal case we are taking surface area as our basis. Okay. Now few more basics we can take, like, see here, the first one I'm going to discuss, that is based on unit volume of reacting flow. Based on unit volume of reacting flow. So here, my dear students, suppose I am writing I for reactant, and this is a standard one also. One question also asked in your GATE examination. Okay. So I generally used for reactant, and J used for product. J used for product. Reactants are going to disappear. गायब होता है सब एक साथ, प्रोडक्ट में बदलता है ना जी. So reactants are going to disappear. Products are going to formed, or if you want to some use some synonym word, then it is going to appeared. प्रकट होना. If your dictionary you are going to check, appears means appearance, प्रकट होना. So definitely for this, whenever you are going to write, you are going to write Ri minus. Sir, is this minus we can use in our numericals? No. In mostly standard books they are using it as a symbol. So also we will use just like a symbol in 99.99% cases. Only 0.1% cases I will use that minus sign, where I will show, don't worry, I will show you. So this is just a symbol. That minus you can't use outside or any numerical, that's why I am closed in the bracket. So when anywhere written like minus Ri like this and use a symbol, what is this? This is rate of disappearance. थोड़ा छोटा लिख रहे हैं बट बोल रहे हैं, तो प्लीज इफ अनेबल टू सी लिसन केयरफुली. दिस इज रेट ऑफ disappearance, but I hope it is enough clear to see. Rate of disappearance, rate of disappearance of I, of reactant I, of reactant I. Okay, everyone clear? Now if I'm writing for J, then J is going to net J is going to produce. So here if plus Rj is written generally, then what is this? This is rate of appearance. Rate of appearance. And one more word you can use here, beta, that is formed. Okay, rate of formation. Rate of formation of J, product J. Okay, everyone crystal clear, beta? Everyone crystal clear? So here I am writing Ri based on unit volume of reacting fluid, and also you can write here beta plus Rj, that is rate of appearance of product J. If you are writing based on unit mass of solid, then the standard symbol that used is Ri dash beta. Here one dash is there. And if you want to write for product side, then you can write Rg dash. So if one dash is there, that means the basis that you are taking is mass, and this is also standard in all books. One dash means the same, so you have to remember, also you have to remember. Okay, so one dash means this is mass of solid. Fantastic. Now where you are going to use it, don't worry, I will tell you just after writing these expressions. Okay, I will give their respective example applications. So here clearly written moles rate of disappearance of I, that means when you are going to write, you can write like moles of I disappeared, moles of I disappeared, disappeared. appeared, whole upon volume of reacting fluid multiplied with time. That's it. Or if you want to write for RJ, you can write moles of J formed, moles of J formed, and whole upon volume multiplied with time. Now, suppose I am asking yaar, please beta write this in some mathematical way. So here when you are going to write very easily. You can write it beta very easily. So for first case, if you are going to write it, you can write it like 1 by V, volume of fluid. Okay. Only the differential thing that is going to change along with time. That is mole and time. Mole and time. So the moles of I disappeared. So this is D and I. With respect to in which time, I am writing in dt time. If in dt time D and I is disappeared. But whenever you are writing something in differential form, what is the meaning of differential? When you're going to integrate initial to final, you are going to integrate. And after putting limit, you are getting final minus initial na yaar. So here if you're writing like final minus initial, so final moles of reactant will be less than the initial na yaar. Just tell me yes or no. Are you getting my words here? Please everyone tell me beta. Please everyone tell me. Are you getting my words? Every student data, please tell me. समझ पा रहे हो ना? No doubts at all. So clearly it is, yeah beta, clearly it is D and I, the sign will be negative after solving. So that's why I told you the value of rate of reaction is a positive quantity. So here you have to put a minus sign because this D and I is negative. But when you are going to write the same thing for this J, then J is a product. If initially the product is 0, then after some time definitely it's 5. But if initially some product is also present in your feed mixture, like 2, definitely after some time the value is going to increase. Final minus initial, already you are getting positive quantity. So that's why here no need to use any negative sign. I hope everyone is able to understand. Okay. Similarly, you can see the second one beta. So here you are writing moles of I disappeared. Disappeared. Okay. And whole upon based upon unit mass of solid. So here you have to write mass. Whose mass? Mass of solid. Completely you can write into notebook mass of solid. So mass into time. Or here you can write moles of J appeared. Moles of J appeared. And whole upon mass of solid into time. I hope beta everyone is able to understand. Hmm? Again, if you want to give them some numerical term, then here you can write it as minus again will be here. And for mass in CRE you will use W. Okay, so minus 1 by W into D and I by dt. Here you can write like 1 by W into D and J by dt. Tell me beta, everyone crystal clear? No doubts at all? बोलो बेटा सभी को क्लियर है ना? कोई डाउट तो नहीं आ रहा ना यार? प्लीज एवरीवन टेल मी बेटा. Everyone tell me. Okay. Crystal clear, sir. Okay, beta. Fantastic. Mind blowing. Super. So, few more terms are there, but I don't want to make this lecture very large. Okay. because initially I will take lecture just 1.5 hour. After a few lecture I will take 2 or 2.5 hour. Okay, sir, Ni is equals to Nj. Beta Neeraj, it is not possible always. Okay, Neeraj, because suppose beta A is forming R, then you can say 1A will give you 1R. But if A is forming 2R, beta 1A will give you 2R. Na? Tell me, beta Neeraj, is it okay? Is it okay, beta Neeraj? So definitely that Ri is equals to Rj, you can't tell. Okay, Ri may equal to Rj. Good question. See, Ri here will be equals to Rj. But here, my dear student, Ri is not equal to Rj. Even both having the same positive quantity. Okay. W is the weight of catalyst. Kya das asking? Yeah, beta. It is actually you are asking weight, but here you will not use the unit of Newton. Weight means the unit must be Newton now. So we will deal here mass beta. So it is mass of catalyst. You can see when you are going to check a packed bed or trickle bed reactor type. So the mass of catalyst you are going to check, that is based upon mass of catalyst the reaction rate. Okay, so because time is over today, so tomorrow I will give these examples to you. Like a reaction is there, if reaction is very slow, mostly the reaction is going to happen in the bulk side. See, I'm giving just an example here. Suppose this is a container, okay, this is a liquid and this is some fluid and going to react with this some gas. So if reaction is very fast, it is going to happen on the surface only. So what is important? Only the surface. Volume, complete volume is not important for you. But if the reaction is very slow, it is penetrating and going to the bulk, and reaction is going to happen inside bulk. Okay, so in this manner definitely the volume is also going to affect the things there. So these examples I'm not in hurry so that I can use today jaldi complete kar de. No, I'm not going to do these things in hurry. I will use very less time for this CRE. Less means complete CRE with more than 36-year solution. And also I will provide with every topic how much questions asked in PYQs. That means just you are going to complete my CRE. No need to see a single page from outside here. Okay, everything will be in your notes. Okay, clear beta? Sir, in the powdered coal example, T1 is more than T2. See here. T1, yeah. Okay, यहाँ पे उल्टा लगा दिया. Good, very good बेटा, very good, very good. ये उल्टा लगा दिया. वैल्यू में तो लिखे हो ना यहाँ पे 10 सेकेंड, यहाँ पे 1 सेकेंड, वो साइन उल्टा लगा दिया. Very good, but Smith. Absolutely correct. T1 will be more. Here 10 second, here 1 second is there. Actually comment भी देखते हैं ना, तो comment देखते देखते फिर यहाँ लग रहा उल्टा लग गया होगा. कोई बात नहीं. सर हम क्या रेफरेंस बुक पढ़ सकते हैं? अरे पढ़ ले भैया, पढ़ ले. रेफरेंस बुक में मेरे से ज्यादा मिल जाए ना लेक्चर से तो बता देना. आई एम गिविंग हियर विथ मोर देन 15 बुक्स एट लीस्ट. आई विल शो बुक्स. I have lots of soft copies and also hard copies. Fogler, Octave Lensfield, you know only these two names, and few maybe you know for all subjects like Coulson Richardson. Here I am using all books, beta. I did these all books, not only these, all few books is not available in India, because if you're going to buy, price is nearly 15,000 to 20,000. वो किताब भी मेरे पास अवेलेबल है, वो भी हमने देखी है. So I am giving here with many books, and also I am giving according to your syllabus, because in books you can see few topics in different manner, something like experimental manner is there. So I am converting everything just like so that you can feel it and you are able to face interview regarding your what is your goal, regarding your goal, regarding your syllabus. Okay, so if you want you can see, but from my side there is no recommendation, there is no foundation, there is no foundation. Okay, but just I am saying my lecture content is more than sufficient. Okay, so today यहाँ पे लेक्चर को हम लोग एंड कर लेते हैं यार. आई एम गोइंग टू बाइंड अप बाइंडिंग दिस सेशन राइट नाउ, एंड अगेन टुमारो वी विल मेट एट द सेम टाइम. ओके, न्यूमेरिकल्स आज नहीं हो पाए, नो प्रॉब्लम. Tomorrow we will see beautiful numericals from this rate of reaction fundamentals. Equations are fundamental. Numericals are also there. Okay, still I am here for next few seconds. If any doubt beta, you can ask me. Thank you, sir. Thank you, sir. Okay, fantastic, mind blowing, super. So, beta, if you want a very great rank, then don't forget to revise your notes every day, beta. At last, in all my lecture, you can see this slide is available. बिकॉज इतनी बार बोलने के बाद भी बहुत सारे बच्चों के दिमाग में घुसता नहीं दैट रिवीजन इज द की फॉर सक्सेस इफ यू वांट रैंक 1 to rank 100 in your rank nearby these ranks, definitely you will be able to join your dream job. And for that, revision is the key. I must do revision daily, I must do daily, I must do daily, I must do revision daily, I must do my revision daily. Okay. But at the rate, the value of rate of fraction will be always positive here, because clearly you can see in both cases that I told you mostly as a symbol you are using in your numericals too. You can see in any numerical they are not going to give its rate is minus 50. They will always give a positive quantity even for a reactant, for a product, it doesn't matter. So that minus sign is available there. Why beta? Because you want to make it a positive quantity. Okay. Is it clear, beta Shan Mukherjee? Is it clear? But Neeraj, you are asking something about pi component. I had sent a message there because this is the start of CRE and we are on YouTube. So I don't want to discuss anything from other subject here. Okay, so either you can ask in CRE too, but only in doubt clearing session. After taking doubt of CRE, I can take doubts of other subjects too. Otherwise, for you, I just told you now on WhatsApp that after this class you can call me. Then I will tell you your doubt. जो आपने doubt पूछा call पे आपको फटाक से clear कर देंगे. Okay. Otherwise, please wait till next live doubt clearing session. Okay. Okay, sir. Chalo. Crystal clear. Take care, but I love you all. A very, very happy good night to all of you. Take care. And tomorrow's lecture stream I will share. You can share with your friends because still these lectures are open on YouTube. So अपने friends के साथ share करना मत भूलना so that you can also feel and complete this CRE. And if they can feel, they can join my guidance. But everyone who want to join all lectures, you can call me, the number below, Rajesh sir number, our director sir number, and you can also connect me if you have any doubt regarding admission, what is fee structure and all. Don't worry, just call me. 9451707049. You can WhatsApp, you can call me for admission beta. Take care, love you all, a very, very happy good night to all of you beta. Okay beta. You're all welcome.